Hello, this is Dr. Lori. Welcome to this discussion on tables. What could possibly go wrong? So what I like to think about in any given situation with epidemiology and biostatistics are what are some of the exceptions. So far this quarter you've learned an awful lot about sort of the basic, normal, what are the typical things that we would do for a variety of different scenarios. What kind of what kind of descriptive statistics would we make? What kind of graph would we make for given variable type? And so I would like to talk about some of the things specifically for tables that can happen within the research process, but then also some specific variable types. So as a reminder, here we have our research process. And we start by asking a question, and that leads us to design a study. Then we look at collecting the data and analyzing it. And then once we've analyzed it, we can interpret what we found, and often that leads us to ask more questions, or other people to even ask questions based on our particular research. What we're talking about right now is this analyzed data piece. And so analyzing data, we can create pictures, and we can create numbers. These are called graphs, and these are generally called tables. And specifically with descriptive statistics, we are simply summarizing one variable at a time. We're not trying to show relationships between variables. So we take this one variable, we try to take all of the individuals in that data set, the values for each person, and then summarize them so that somebody could look at that, and instead of looking at 2,000 rows of data, they can look at a picture, or they can look at a summary, a number that summarizes all of that data in one place. Now, the problem that can happen, especially early on when somebody's learning about the research process, is that what we do when we analyze it does not match the question and does not match the interpretation. So just be really clear about what question you're trying to answer. And then as you're building your table with the numbers in it, then make sure that that really relates to that specific question that we're trying to answer. So that's one of the things that I often see within any given project. So that's something to keep in mind as you go through this. The other thing is that we've learned quite a bit about kind of the basic things about descriptive statistics. We call these categorical, we call these scale, and when we do the descriptive statistics for categorical variables, we typically do count or frequency along with whatever the percentage is, and then for the scale variables that would be mean and standard deviation. We learned about an exception where ordinal has 8 or more categories and it gets promoted to be this wonderful in-between category. Or scale really isn't normally distributed, so when we use the mean and standard deviation, it may be confusing or misrepresent what we're finding in our particular data set. And so in this case, we would use the median and some kind of a range, either interquartile range or the full range, to represent that. The graphs then, of course, are histogram, box and whiskers or box plot, and typically a bar graph or a pie. So we've learned all of those kinds of things that relate to the different variable types. I would like to add one more layer, and this is really only specifically having to do with the scale variable. And we've started to get into some real data, and so we're starting to see some kind of interesting things. So with scale variables, there are 2 different kinds of scale variables. One is continuous, and one is discrete. Is that an E? Discrete? Discrete? I don't know. And the confusing part is often we use scale and continuous to mean the same thing. We use them interchangeably. But really there's sort of like this umbrella that encompasses these two types of variables, continuous versus discrete. What continuous means is that there's an unlimited number of gradations in between. So if we have something like height, that's a great example. If you ask anybody what their height is, they generally tell you in full either centimeters or inches. But in reality, people don't end up being 5'3", and then there's nobody in between all the way up to 5'4", and then there's nobody in between all the way up into 5'5", and so forth. Really, there's this continuum, and people report what they're the closest to. And so when we make a histogram of that, we put people into these kind of bins, and they're touching. They are touching. And this really represents that the width of that bar represents the fact that height really spreads incrementally. And if we could measure to the finest degree, if we had hundreds of people all together, they would probably all actually be different heights because of this very fine gradation that's possible. There's unlimited number of possible choices in between. Discrete, on the other hand, is where you only have whole numbers. So 1, 2, 3, 4, and so forth. Number of siblings is a perfect example of this. You can't ever have 2.5 children in a family, for example. There's either 1 or 2 or 3 or 4. And so for that kind of a variable, the interesting thing that can happen, technically it's scale. Remember, we're talking, all of these are scale variables. But what can happen is if there are only a few categories in a particular data set, then that variable can sometimes behave more as if it's a categorical variable, specifically ordinal. And here's why. If we have very few categories and it's not normally distributed, for example, and we'll see an example of this, then if we try to turn it into a variable that we calculate the median and interquartile range and create a box plot, we end up with some problems. When we're creating a box plot, remember we have this box. I'll draw a little box. And then we have little whiskers sticking out. What we're essentially doing, I'll get a different color, is we're lumping the data into 4 groups. We're saying, oh, we're trying to make 4 approximately even groups, and here are our 4 groups. Well, let me erase something here. What if we only have 3 groups in this particular discrete variable? We have 1, 2, or 3 children per family. How do you divide that into 4 different categories? It makes your box plot not really represent what you're trying to show. It makes your median and interquartile range really sort of deceptive. And so if you have a scale variable that has discrete categories and there aren't very many of them, and it's not normally distributed, then you may have to actually drop down here to be an ordinal variable and report the count and percent and use a bar graph or a pie graph instead to show the descriptive statistics and the graph for that particular variable. So that's just kind of like an extra layer on top of what we originally have been learning. We started out with the basic things and then we keep adding layers. The thing that I think a lot of people find out is that statistics isn't quite as black and white as they imagined. And so if you were coming to statistics thinking, oh, well, it's going to give us a yes or no answer, a lot of times we have a lot of gray area in statistics. And so that's one of the things to consider. So let's take a look at some graphs. Here is an example of sort of what I was talking about, and we have PE attendance, and then, oops, I didn't mean to cover that up. Let's get rid of that. I'll just underline it. We have PE attendance, and then we have how many days did you have PE per week, maybe. I'm not sure exactly how the question goes, but maybe this past week or over the past month on average, something like that. And so a bunch of kids, nearly half, said 0. And a bunch more kids, probably about a quarter of them, said 5 days. And so if we were to look at this variable, would you say that it's very normally distributed? Most people would say that it's more like it's bimodal. So we've got these two modes, and then we've got this whole empty area in the middle. We've got a few with 1 day, a few with 2 days, a few more with 3 days, and some with 4 days, but definitely heavy on the ends. And so if we tried to create a mean and a standard deviation, that would not really accurately represent what we're seeing here. We might come up with some kind of a mean like 3 days, but that's really not the majority of students. That's a pretty small group that has 3 days. And if we tried to put this into some kind of a box plot and report the median, we'd end up with the same exact issue. The median is going to be somewhere around 3 days, but that really is not representing the bulk of the students. And so using a bar graph for this particular one and then the associated statistics that go with it may end up being the very best that we can do for that particular variable. Let's take a look at a couple of more. And here's an example of age here. How old are you? And what has ended up happening is it looks like it could be a scale variable, right? We have 14, 15, 16, 17, 18, 13, 12, right? However, the problem that we ended up with is that we have years or older. So that this could include 19-year-olds, or if for some reason somebody is extended in high school all the way up to 20, and this bottom category is 12 years or younger. Now if you look at the actual frequencies, I think this is 9 and this is 3, and then we get to be more like real numbers, somewhere around 180 or something like that. So the thing that I wanted to point out specifically with this one is because of these problems that we have on the ends, we really can't turn this into a scale variable. Or if we did, we would have to explain that in our reasoning, that we know that those end categories could include some teenagers that are, or could include some high school age kids who are not 18 or not 12. But then the other thing that I wanted to point out is because these bottom two categories are so small, some people would argue that it would be beneficial to go ahead and combine them. And some people would even combine them with the 14-year-olds. So that's one of the things to think about, is if you have an example of things where you've got these really small categories, you may want to consider lumping them together, just realizing that it's unusual for a 12-year-old or a 13-year-old to be in high school. And so just kind of allowing them to be in that bottom group might be okay, depending on the research, again, depending on the research question that you have. So it kind of all goes back to this question up here, the big idea. So that's age. Here's another one, specifically with race ethnicity. Here's an example of a time when you may want to put these categories in order. And you also may want to group some categories together. Sometimes, again, depending on your research question, you would like to see these different categories separately, and sometimes and I would specifically actually keep Black or African American separate. But sometimes we will include white, Black, Hispanic, so non-Hispanic white, non-Hispanic black, and Hispanic, and then lump the other ones into other. And if you were to put those in order of the frequencies, then that often makes sense. What I usually see in that particular case is that the multiple is not lumped into that continuum, although I have seen it included. And so if multiple is the second largest category, then it would be white, then multiple, and so forth. So you really do have a lot of options when it comes to nominal variables. So this is more ordinal, and so we really want to keep those in order. For nominal, we have some flexibility there to be able to show different kinds of things in a different sort of way. The next two graphs really point out kind of the same detail, and that is that if you have a category down here at the bottom that is did not drive, that's like a not applicable almost. What you want to do is make sure that you have that either at the far left of the graph or at the far right. Here, because did not drive is kind of like closer to I didn't drive, I never drove while I was drinking, then we put it here on the left hand side. Some graphs would leave this off entirely, just and say of those who are drivers, how many of them would drink and drive. And this would be an example where you would not put these in order of frequency, because then the 6 or more would end up there, and you would confuse the person who is trying to figure out how to interpret this particular information. So we would definitely not do that. The same thing happens over here with soda drinking, and a lot of you, I think, figured out that this 1 to 3 times is per week, and 4 to 6 times per week, and then this starts being per day. So that makes perfect sense. We have the zeros, and then 1 to 3 times per week, 4 to 6 times per week. As soon as it's 7 times per week, then that's once a day on average, right? And then twice a day, and then 3 times a day, and 4 or more times a day. And notice how this goes up, because there are probably people who have 4 or 5 or, 10 sodas per day. And so you end up with that category that sort of is, again, lumping a bunch of things together. All of the things that we talked about relative to these graphs that we've seen already also apply to the way you put things in order in your table. And so however it is that you would create a graph, whether you have the graph in that particular report or not, those same kinds of principles apply, in that you really want to use the kind of statistic that's going to convey the information that you want. In this case, even if you don't have a graph, you still probably would not use mean and standard deviation, just because it's not really representing the data. In the cases of these other variables, putting things in order in certain ways, including or not including things, and then very clearly make sure that you're always very clearly labeling things. You may even want to go back into your data set and relabel those particular categories, just so that it's super clear on any graph that you create, and you would want to include all of that terminology on any kind of table to make sure that it's really it flows, it's obvious that those things are in order. That has to do with kind of the table should be able to stand on its own and be clear to the person who's looking at it. So that concludes this discussion on the things that could be unusual about tables.